This is a fourth video on ANOVA, and in this video also I am going to solve another problem on one-way analysis of variance. This is second video, and in my earlier video also I showed you how to solve a problem, and in this video I will solve a problem where k level samples having different sample size. So for each k levels, if you have different sample size, how to consider, you will come to know in this video. This video PPT is also available in the description box, and also how to enter data and analyze and interpret one-way ANOVA in SPSS video is also available in the description box. You can go through that. Then let us consider a problem for this. Here we have a problem in that an investigator is interested to know the level of knowledge about the history of India of 4 different schools in a city. So there is an investigator, he wants to know the level of knowledge about history of India in different schools. Say for example, in this example we have taken 4 schools, and a test is given to 5, 6, 7, 6 students of 8th class of 4 schools. So for first schools, they have given a test for 5 students. For second school, they have given a test for 6 students, and 7 students, 6 students for third and fourth school respectively. And their scores out of 10 is given below. So which means it is very clear we have 4 schools and we want to know the level of knowledge of history of India, and for students they have given a test, and the test score is also obtained as follows. So from first school 1, 2, 3, 4, 5 students, second school 6 students, third school 7 students, and fourth school 6 students. And we can see their score of history of India out of 10, their obtained scores you can see in this table. So in this situation we have 4 sample, so we cannot go for 2 sample t-test. And very importantly, an investigator is interested to know the level of knowledge about the history of India. So when we wants to consider more than 2 groups, we have to go for ANOVA. And in this example we have to decide whether we are going to consider this situation under one-way ANOVA or two-way ANOVA. Since there is only one category, that is a school category, under school factor we have 4 schools, and we don't have one more category here, so we can go for one-way ANOVA in this situation. It means only one factor under study is considered, that is knowledge about the history of India of 4 different schools in the city. So we want to know whether the knowledge of history of India in all the schools differ or do not differ. So let us see some of the procedure for this. In my second video I have clearly explained about steps for calculating one-way ANOVA. Here I will just glance it for your convenience. Firstly, we have to set up null and alternative hypothesis, and we have to find grand total and correction factor. For correction factor, g square by n, number of sample, raw sum of square, total sum of square. For total sum of square, it is a formula RSS minus CF. Sum of square due to treatment, sum of square due to error, for that TSS minus SST, and sum of square, mean sum of square due to treatment, and mean sum of square due to error, finally F ratio. These are the very important steps you need to follow to solve the one-way ANOVA, and finally you need to give a conclusion. So let us formulate a null and alternative hypothesis for this. So step 1 is set up null and alternative hypothesis. In this example we have 4 schools, 4 different schools in the city. So mu1, mu2, mu3 and mu4 denote average score of students of 8th class of schools 1, 2, 3, 4 respectively. Let us denote those schools in the mathematical formulation. Then our null hypothesis would be mu1 equal to mu2 equals to mu3 equals to mu4, which means difference among mu1, mu2, mu3 and mu4 are insignificant. which means I am saying I am imagine or else I am assuming level of knowledge of history of India in 4 different schools do not differ. There is no difference. So all are same. If you want to know how to formulate null and alternative hypothesis, I have made a separate video on formulation of null and alternative hypothesis, type 1 error and type 2 error, and so many videos. You can access those video in the description box. So accordingly you can formulate null and alternative hypothesis. Since null hypothesis is difference among mu1, mu2, mu3 and mu4 are significant, alternative hypothesis must be opposite to null hypothesis. So my alternative hypothesis is mu1 not equal to mu2, not equal to mu3, not equal to mu4, which means difference among mu1, mu2, mu3, mu4, which means different schools are significant. In the sense there is a significant difference between different schools students about the level of knowledge of history of India. So based on this assumption hypothesis, let us solve the problem, and finally we can take a conclusion. We can take a decision over it. So let us go for second step. Before that, we have to prepare this tabulation. If you prepare this tabulation, then the whole calculation will be easier. So here school 1 data, we have 5 students in the school 1, we have 6 students in the school 2, and we have 7 students in the school 3, and we have 6 students in the school 4. Firstly, I have listed here whatever the data given in the problem. So from school 1 out of 10 score 8, 6, 7, 5, 9 from all 5 students, and school 2 6, 4, 6, 5, 6, 7, and school 3 6, 5, 5, 6, 7, 7, 8, 5, and from school 4 5, 6, 6, 7, 6, 7. Now firstly what we want to do is we have to make a square of each sample. So that is S1 square, S2 square, S3 square and S4 square. So 8 square is 64, 6 square 36, 7 into 7 49, 5 into 5 25, 9 into 9 81, and so on. I have squared all the values of from all 4 schools. After taking a square of all the sample data, we have to add all the details, all the sample data and square data, and so total of school 1 is 35, total of school 2 is 34, school 3 is 42 and school 4 is 37, and S1 square of school 1 is 255 and school 2 is 198 and school 3 is 260 and school 4 is 231. Very firstly we need to prepare this data. After this preparing this data, we can take directly amount into the formula. So it will become very easy once you prepare this tabulation, and there is nothing in this tabulation, just feed the data whatever you have in the problem and make each and every sample as square. So then let us move to the step 2. So the step 2 is we have to find the grand total of K's, all the K levels in the given situation. So we have 4 K's here, which means 4 schools. Take the 4 schools total and add all together, it will become a grand total. So this is 35 and this is 34 and this one is 42 and this one is 37. When we add all these together, grand total of all 4 schools is 148. So we can go for third step then. Once we found the second step, third step is correction factor. So we know that correction factor formula for correction factor, G square, that's a grand total divided by N. N includes N1, N2, N3 and N4, which means we have 4 schools in this example. We have to take all the schools sample size, then we can divide that by grand total, then we will have correction factor. So you know that G square is 148 here. I have taken it directly. Since we have to make a square first, I have given a square here, and 24 n1 n2 n3 n4 is 24. You will see how it is. That is what I am attempting in this video, because we have different sample size in this example. From school for 1 we have 1 2 3 4 5 student sample. From school 2 we have 6 student sample. From school 3 we have 7 student sample. From school 4 we have 6 student sample. 6 6 7 plus 5, if we add all together it is 24. So number of sample in this example is 24. So firstly I have squared the 148. The 148 is 21,904 and divided by 4. Then my correction factor is 912.66666. So this is the correction factor for this given example. Then let us move for finding sum of squares in the further steps. In the sum of square, first let us calculate raw sum of square. I have told you in the earlier video why I have prepared this table is to take directly. This is quite tedious calculation for finding raw sum of square. That's why we have prepared this table. So what does it raw sum of square? We have to make a square of all raw data, that is sample size of all 4 school. We have made a square. Since it is a raw data, we have taken a raw sum of square, and once we square the raw data we have to make it sum. So we have squared the raw data, 8 into 8 64, 6 into 6 36, like that we have squared the raw data, and at the end we have to sum all the squared raw data. So that is what raw sum of square. In this table I have squared all the raw data first, and at the end I have added each school squared data. So what is this formula? Summation k. K means number of schools in this example, and ni is sample size of each school. Let's take a individual sample size like that, and y to ij. So when we make a summation of all these data after taking square, we will get this raw sum of square. So then let us consider that directly. So 255 is a raw sum of square of first school. 298 is a raw sum of square of second school. Here that is I have added here, and 260 is third school. 231 is fourth school. So when we add all these for all 4 data together, so we got a raw sum of square of 944. Then let's go for fifth step, that is total sum of square. The formula for TSS is raw sum of square minus correction factor. Raw sum of square we have already calculated 944, and correction factor we have calculated in the third step, that is 912.667. So when we subtract 912.667 by 944, we got total sum of square in this example as 31.33333. So by this way we also found total sum of square. Then let us move to the next step. Again we need to consider sum of square. We have one more sum of square, that is SST and SSE. So sum of square due to treatment, which means we have to consider each category. So we have 4 categories here, that is T1 I will consider this first column value, and T2, T3, Tn means we can consider like infinity, and each thing will be divided by their respected sample size, and after that it will be subtracted by correction factor. So let us take the values then. Firstly in the first column the sum of the value is 35 square, so and number of sample size is 5 in the first school, so 35 square by 5, and in the second school we have 6 sample and total value is 34 square by 6, and in the third school we have 7 sample and total value is 42, so 42 square by 7, and in the fourth school we have 6 sample with 37. So 37 square by 6 minus correction factor is 912.667. So 35 into 35 divided by 5 is 245, 34 into 34 by 6, 192.67. 42 into 42 by 7, 252. 37 into 37 by 6, 228.167 minus correction factor. So firstly I have added all the positive values, that is 917.837, and correction factor carried as it is, and when I subtract this but by correction factor, SST is 5.17. So by this way, by subtracting with the correction factor, we found SST also. And in the next step, let us find the SSE, that is sum of square due to errors. So we know that formula for sum of square due to error, that is TSS minus SST. SST, just we found the value of SST. So the TSS and SST, we have the TSS just we found in the earlier step, that is 31.33, and SST 5.17. When we subtract SST by TSS, we got our SSE value. So 31.33 minus 5.17, 26.16 is sum of square due to errors. Then let us calculate mean sum of squares. In the mean sum of square, we have two steps, that is mean sum of square due to treatment. Firstly, let us find out mean sum of square due to treatment. We know that formula for calculating mean sum of square due to treatment, that is SST by K minus 1, and SST we have already calculated SST, that is 5.17, and now we want to know K. As I keep on saying you, we have 4 schools in this example, 4 schools, that is S1, S2, S3 and S4. So K means number of groups. So we have 4 groups here, then K is 4, 4 minus 1, and SST is 5.17, and 5.17 by 3 we will get MSST is 1.723. So then let's go for MSSE, that is mean sum of square due to errors, and we know that formula, that SSE by n minus k. Since we are dealing with mean sum of square due to errors, we have to take sum of square due to errors. So we know that n is 24 in this example, because from school 1 we have 5 sample, from school 2 we have 6 sample, from school 3 we have 7 sample, and at the end from school 4 we have 6 sample. When we add all these 4 school sample, we know that our sample sizes in this example is 24, and we know that we have 4 schools here. So K is 4, 24 minus 4 is our degree of freedom for this example. So SSE is 26.16 and N is 24 and K is 4. So 26.16 by 20, it would be MSSE. MSSE is 1.308. So by this way we calculated all the steps except F ratio. F ratio let's calculate in the table only. So let us see table again to glance at your mind. This is a table, so we have to consider treatment here, we have to consider error. We have 2 treatment, SST and MSST, here SST and here MSST. We have 2 errors here, that is SSE and MSSE, and for MSST we know the degree of freedom is K minus 1, from MSSE we know the degree of freedom is N minus K, and for calculate the total things, the degree of freedom is N minus 1. And here I will take total sum of square, since we are dealing this column with the sum of square. SST plus SSE is total sum of square, and F ratio, for F ratio MSST by MSSE we will get a F ratio. Then let us make a tabulation for this. Then we have given a treatment between 4 schools we have given a treatment, that is a treatment. So here treatment given for between school, and this is a V1, and we have found error within the school, that is V2. So error is within school and treatment is between schools. And degree of freedom K is 4 in this example, K minus 1, so that is 3, and N minus K, N is 24 and minus 4, K is 4, and that degree of freedom 20, and this is n minus 1. N is 24 minus 1 is equal to 23, and 3 plus 20, it must be the equal value. We must get a same value when we add this two column, and sum of square is 5.17, and sum of square due to error is 26.13. So total sum of square is 31.33. When we add these two, SST plus SSE must be TSS. So here I have just inserted the things we found. Here we have a TSS, we found it in earlier steps. We have SST, we have SSE, and MSST, that is 1.723 MSST, and MSSE 1.308. all the values we have here. And we know the formula for calculating F ratio, that is a variance ratio. So that is MSST by MSSE. MSST is 1.723, MSST is 1.723, and MSSE is 1.308. So our F ratio is 1.317. This is F calculated value. So after finding that calculated value, you all know that we have to see the tabulated value, and then we can compare calculated value with tabulated value. Finally, we can come to a decision whether to accept the null hypothesis or fail to accept the null hypothesis. Then let us see the table first, that is F distribution. In my last video, I told you how to read this table. So firstly, we need degree of freedom, that is V1 and V2, and alpha level. So this is for 10% alpha, that is 0.1, and our we have to, since in this problem they have not mentioned about significance level, when they have not mentioned about significance level, we have to imagine that 5% alpha, this is appropriate for n study. So then let us go for 5% alpha, since that is this is a 5% alpha, table for 5% alpha, and V1, that is treatment. Here in the row we can see the treatment, this row we can see the treatment under that heading, and in the column here 1 2 3, this is our within school, so that is error. So error is V2, and between school is V1. So firstly we need to know the degree of freedom for this problem. Here you can see between school we have V1, that's 3, and within school we have degree of freedom 20. We have to see V1 3A and V2 20. So V1, this is this arrow mark is V1, I told you already. So V1 is 3, this is V1 3, and V2 is 20. V2 is 20. So if we see that this is the value, that 3.10 is a table value for 3 numerator and 20 denominator at 5% level of significance. So then let us finally compare this tabulated value with calculated value, and finally we can take a decision over it. So we know that our calculated value is 1.317, and we saw table at 5% level of significance for V1 3 and V2 20 degree of freedom. So our tabulated value is 3.10. So I told you in my last video only when to accept null hypothesis, when to fail to when we will be in a position to fail to accept the null hypothesis, when the calculated value lesser than table value. When the calculated value is lesser than table value, then we have to accept the null hypothesis. We have to accept the null hypothesis. When it is opposite situation, we have to reject the null hypothesis. That's very simple. There is no confusion over it. So in this example, since calculated value is 1.317 and table value is 3.17, so calculated value, F calculated value is lesser than F table value. So we may say that we have to accept the null hypothesis and conclude that the level of knowledge of schools 1, 2, 3 and 4 do not significantly differ. So our null hypothesis is mu1, mu2, mu3 and mu4 do not differ significantly, and our alternative hypothesis is mu1 not equal to mu2 not equal to mu3 not equal to mu4. So when we accept null hypothesis, we have to accept that claim. So the claim is there is no significant difference between four schools. So since we have accepted null hypothesis, we can say there is no significant difference between four schools. So for more details, you can study this material, the Introduction to Analysis of Variance, the IGNO material. And I hope you got a thorough understanding about one-way ANOVA. In my next video, I will start two-way ANOVA. I will consider two factors for calculating a problem. So the PPT of this video is available in the description box, and hypothesis formulation video is also available in the description box, and how to enter data and analyze data in SPSS for ANOVA is also available in the description box. Please don't forget to subscribe to my Vision Academy YouTube channel. Thank you so much for watching this video.